Hello everyone. This is section 3.1. Well, if you go to the schedule, yes, the 3.1 is actually basically it's supposed to be covered on Tuesday. All right, and well, 2.8 is supposed to be covered on Monday, but I covered this 2.8 on Thursday. All right, so last week Thursday video was 2.8, section 2.8 video. All right, and so that means I should have covered 2.9 on Monday, right? But what I decided is that I decided to skip 2.9 for right now. I might cover that later on in the semester, but for right now I decided to skip 2.9. Okay, so that means I will be covering 3.1 for Monday lecture. So that means for Monday and Tuesday, you will just have one lecture, which is just going to be of 3.1, section 3.1. So that means I'm not going to upload any video for Tuesday. So this video is going to be for Monday, and there won't be anything for Tuesday. All right, so basically I'm combining, or you can just think like, okay, I'm combining 2 days lecture on just one video. All right, so basically what I'm trying to say here is I'm trying to just skip this section 2.9 for right now. Okay. And also, okay, so that means the wave assign homework of section 2.7 and 2.8, which I gave you guys lecture last week. So the homework, wave assign homework for this one is going to be due this coming Saturday, which is September 26th, 11:59 p.m. So I'm giving you guys more than enough time to do these homeworks, right? It's pretty much like more than a week, because I covered this section last week. So that means, well, if this is due this coming Saturday, that means I'm giving you more than 1 week, right? Okay, and if I assign any quiz in this video, since I'm combining both Monday and Tuesday lecture in this video, so I'll just make anything or any quiz assigned in this video, the due for that one is going to be this Wednesday, September 29. All right. Okay, let's start section 3.1. Like I said, this is going to be Monday and Tuesday lecture, combining basically both in one lecture. Okay, so the first thing here we're going to talk here is going to be about minimum and maximum values. All right, so minimum maximum value. Okay, I'm going to talk about the absolute maximum. All right, just wrote max, which means maximum, and here I wrote min, which means minimum. All right. Well, here the idea is, okay, so let's read these things. Okay, so let C be a number in the interval m and n. So this interval is going to be on x-axis. All right. So let's say the m is right here, n is here, and there is a number C in the interval. So the C could be anywhere in this interval, in between these two numbers. All right. Then FC is, okay, let's say if C is, okay, right here, and let's say we get a graph something like this in this interval. Okay, then here we get FC means, well, if we give some value on x-axis, this FC means we'll get that value on y-axis, right? So FC should be somewhere down here, right? Okay, so now this point, that means f of C. Well, f of C is absolute maximum. We call this point the absolute maximum on this interval, right? On m and n. If f of C is greater than equals to f of x for any x in m and n. So that means there could be any other x values. X value could be anything. Okay, there is another x value, which is again in this interval. So if I pick any x here, let's say if I pick x here, that x, well, f of x is obviously going to be less than f of c, right? That's what I'm saying here, right? If I pick this x here, this f of x is obviously less than f of c, right? So in that case, this point, we call this f of c point absolute max, right? ABS means absolute. Okay, and similarly, same concept. Okay, there is another interval, let's say m and n, and let's say if we have a graph something like this, and there is a c here, which is obviously in between this interval, right? The absolute value of f on m and n, and then if now this f of c is obviously going to be, well, when you're taking this interval m and n, so in this interval f of c is obviously going to be absolute minimum, right? Because if I pick any x again, just like I did here, any x, let's just say here, so that means from here our f of x is obviously going to be this point. F of x is obviously going to be greater than f of c, right? So that means at this point f of c point is called absolute minimum. All right, that's the idea of this definitions, whatever I explain here. Okay, and the next one is now it's local maximum and local minimum. So again, the definition is, it's pretty similar. Now here, when you're talking about the absolute maximum minimum, we consider the interval, but here what we're going to consider here is x is near to c. Okay, so if I say something like this, there is x value here, or there is c here, okay, and that means the f of c is going to be somewhere down here. So there is any x which is near, so that means x is basically approaching towards c, but it's not exactly c, right? X is near c. So that means if any x that is near c, and if we still get f of c, but basically any x that is approaching, right, towards c, but it's not exactly c, then f of c is greater than equals to f of x, then this f of c, we call this a local minimum, sorry, here, oops, yeah, but it's same thing, sorry, minimum. So in this case, we call this minimum, right? And similarly, when we have a graph something like this, and again, if I say c is here, and again, x is approaching towards c, x is near c, then this point here, we call this point f of c local maximum. All right, so this one we call local minimum, this one we call local maximum. All right, clear? Okay, now let's go to another one. Okay, now another one is Fermat's theorem. So this theorem basically says that, okay, let's say if f has local max or local minimum at certain point, in this case again we are saying at c, and okay, so let's say there is a c here on x-axis. So when we see at this point we get f of c, so we can say that at this point we get local, on this graph we get, at this point we get local maximum point, right? We're saying either local max or local mean here, right? It could be anything, either local max or local mean. But now, and if f of or f prime of c exist, all right, so what does f prime of c means? Okay, so whenever we find, whenever we take the derivative at certain point, that means it is the slope of the tangent line well, at that point, whatever point is there. So here we have C, so at C, okay? So on the maximum point, at the maximum point, the slope of the, or basically the tangent line is basically, tangent line means it is a line which is just gonna touch the graph at just one point, right? So that means at this point, the graph, well, we cannot touch this point like this, because in that case, well, we will be touching this graph more than once. So since it is a tangent line, so there will be a horizontal line like this, which will just touch this this point. Of course, this line is basically, well, if you zoom in, probably it's going to touch more than once, but what I'm trying to explain here is, okay, this line is just touching this graph here at this point, okay? And well, this is horizontal line. So that means, now this means here, this means it is the slope of the tangent line at this point, and basically that means we are finding the slope of this horizontal line, right? So the slope of the horizontal line, okay, this is one fact. This one is another fact. Slope of a horizontal line is always equals to 0. Okay, this is algebra. All right, I'm not going to prove this, but you can in this class. But you can just okay, you can just take any point on this line and find the slope of this line. You will get the slope of this line 0. Okay. So what I'm trying to say here is, okay, so that means the slope of this, so okay, so that means the slope of this line is, so here, that means we'll get f of f prime of c is equals to 0. All right, so I just did a scratch of this proof. This is not exactly the proof, but let's say I might ask you in the exam, well, I might ask something related to with these things. Okay, so if you understand this idea, you can definitely answer the problem that I asked in the exam. All right, so make sure you understand this this idea. All right. Okay, now let's go to another one. Okay, now let's go to critical number. So the critical number, okay, so again, the definition of the critical number is a number C on the domain of F. Again, the domain of F means it's going to be basically, we're just going to think it's going to be an x-axis of F, such that, okay, such that if F prime of C is equals to 0 or F prime of C doesn't exist. All right, so what I'm trying to say here is we can get the value of C when we take the derivative of F and set that is equals to 0 and then find the value of C. Or you can also find the critical number where F of C doesn't exist, but F, okay, the derivative of C doesn't exist, but F of C still exists. Okay, so I'll also an example of this. Okay, so first let's do this example. Okay, let's find the critical number of this function. Okay, so so this is a regular polynomial, right? Basically, this second statement is used when we have a fraction. When you're dealing with a fraction. On a polynomial something like this. So when we have a polynomial function, something like this, you can, most of the time you'll be just using number one conditions, all right? Most of the time. It's not always, but most of the time. Okay, anyway, okay, first now here to find the critical number, okay, first we need to take the derivative of this function. All right, f prime of x is equals to, okay, so here 2 will stay there. We bring 3 down here, x square plus, okay, we'll bring this 2 down here, so which will be 2 times 5, 10. X to the power 2 minus 1 is just 1. Here 3 times 2 is just 6, right? Okay, now after this, we have to say, okay, now to find the critical number, we have to say now this is equals to 0. And then, okay, now we already found f prime of x, which is 6x squared plus 10x is equals to 0. So from these two, okay, from 6 and 10, we can factor out 2. From x squared and x, we can factor out x. So that means I get 3x here plus 5 is equals to 0, right? Okay, so that means now here we get either 2x is equals to 0 or 3x plus 5 is equals to 0, right? That's, again, this is algebra. Now divide 2 on both sides. So x is equals to 0 or x is equals to negative 5 over 3, right? Okay, so that means now whenever you're dealing with a polynomial, basically whatever value you get at the end, these two should be critical numbers. Okay, whenever you're dealing with a polynomial function, okay. So that means, again, let's see if we have a polynomial function, something like this, and again we need to find the critical number of this function. So again, you need to find the derivative first. So the derivative here will be, okay, I'll now, well, by this point I expect that you understand how to get the derivative, right? Or at least whatever I explained on previous videos using power rule. I think you can get that, right? So here 3x squared, I'll bring this 2 down here, so 6 times 2 is 12. X to the power 2 minus 1 is still 1, minus here, and the derivative of x is just 1, so still we have 15. All right, and then now again, you said this is equals to 0, and we already found the value of f prime of x, which is this whole thing, so 3x squared plus 12x minus 15 is equals to 0. So from all of these, you can factor out 3. So 4x minus 5 is equals to 0. And then divide both sides by 3. So we just have x squared plus 4x minus 5 is equals to 0. All right, so now from here, okay, it's a quadratic function. You can find the value of the x either using a quadratic formula, or we can simply, okay, well, basically we can just multiply 5 and 1. So which will make here, it will make x plus 5 and x minus 1, because 5, positive 5 and negative 1 will make positive 4, right? Okay, so from here I'll get x is equals to 5, and here I'll get x is equals to negative 1. So again, in this case, since again this is a polynomial, so whenever you're working with the polynomial function, so whatever the x value you get at the end, that should be the critical number. So in this case, okay, we have two critical numbers, right? Okay, but what about when you are dealing with a fraction, right? Like I said here, so when you deal with a fraction, we need to consider this second part as well. Okay, so again, the process is same. We need to find the derivative of this, but here we have a fraction, right? So when you're taking the derivative of fraction, we're using the product rule, right? So when you're dealing with the product rule, so if you're finding the derivative of, let's say, f of x is equals to h of x over g of x, then when you're finding the derivative of this, then in this case, we first take the derivative of numerator, denominator will be same, minus, now the numerator will be the same, and then take the derivative of the denominator over denominator square, right? So here, okay, so now here we take the derivative of, okay, it should be, sorry, x square. Okay, so when you take the derivative of the numerator first, right? When you take the derivative of the numerator, we'll get 2x, and the denominator will be the same, minus, now the numerator will be the same, right? Just h of x, x square, and when you take the derivative of the denominator, again, the x square is 2x, and when you take the derivative of 9, it's 0, so we don't have to write that, over x square minus 9, right? So again, from here, now distribute this, so 2x, distribute this to these two values, so 2x cubed minus 18x minus 2x cubed. Oops, here I should have say x, the square, right? And then on the denominator we get square, right? Over x square minus 9 square. Okay, now here this and this one goes out, so that means we just have negative 18x over x square minus 9 square. Okay, so now here, like I said, when you are dealing with a fraction, you need to consider both case. All right, you have to consider either f prime of c is equals to 0, or find the value of c where f prime of c doesn't exist, but f of c still exists. Okay, so oops. Okay, so that means, okay, the first condition we can use here is we can use here as, okay, so here first condition we can say, okay, now let's say f prime of x is equals to 0, and f prime of x is this one, negative 18x over x square minus 9 square is equals to 0, right? So now here we have x on the top, and we have this thing whole on the bottom. So now to find the value of x, what we can do is just multiply this x square minus 9 whole square on both sides, right? So that way we will just have, on the left hand side, we'll just have negative 18x is equals to 0, right? Basically, I'm just multiplying this thing, denominator thing, on both sides, right? So here, when you divide negative 18 on both sides, I get x is equals to 0. Okay, so now when you're dealing with a fraction, okay, now when you get the x value, plug this x value to the original equation and see if you get any undefined function. But when I plug this x is equals to the original equation, on the top I'll get 0, right? On the bottom I will get 0 square minus 9. So basically what okay, let me just write that. This is a scratch. See, oops. This is a scratch work. So when I plug this into this equation, I will get, okay, on the top I'll get 0, On the bottom, I'll get -9. So 0 over some number is always a 0. Okay, so this works. This is not undefined, right? This is not undefined. Okay, so this works. Similarly, now the second conditions here, it says that we need to find, so basically this one, but f of c still exists. Okay, this condition is for both of these. All right, now on the second one, we need to find the value of c where f prime of c doesn't exist. Or basically what I'm trying to say here is, from this f prime of x, from this equation, we need to find the value of x where this whole equation is going to be undefined. Okay, so now how can we find that? All right, so we can find that, well, basically, and when you deal with a fraction, how can we find that is basically when we have a 0 on the bottom, in the fraction we get that undefined, right? So it doesn't matter whatever we have on the top. Anything on the top divided by 0 is always undefined. So it looks like here, since we have -9, right? So if I choose, let's say x is equals to 3 or x is equals to -3, how can we find that? Is, well, we can find that when we say that the denominator is 0, because we don't want denominator 0, right? So if I say denominator is 0, okay, first let's just take square root on both sides, because I have this big square, right? So to get rid of that, I can take all right, so that means I'll just get x squared minus 9 is equals to 0. Move this to the other side, so x squared is equals to 9. So now again take the square root, so x is equals to plus minus 3, right? So that means if I take x is equals to plus 3, here I'll get 3 squared minus 0. So here I'll get, doesn't matter what we have on the top. Here I'll get something on the top, right? Something on the top divide by, so if I say x is 3, then 3 squared is 9. 9 minus 9 square, or 9 minus 9 is 0. So anything divided by 0 is undefined, right? Similarly, if I pick -3, we still get undefined. Okay, so that means, okay, we got this condition. We got the value of c where f prime of c doesn't exist. But now f of c must exist. But what we can see here is, let me just write this here. Okay, what we can see here is we got x is equals to plus 3 and minus 3. Now, but when I take this to the original equation, our original equation is, what is our original equation? X squared over x squared minus 9. Okay, so when I take plug this into the original equation, what I get here is, doesn't matter if I take positive or -3. On the top I will get 9, on the bottom I'll get 9 minus 9, which is 9 over 0. Okay, so that means here this conditions, or these number doesn't work, just because of fc must exist. All right, but we got, when I plug this into the original equation, we get undefined. All right, so that means our critical number is just this one. Okay, so make sure you understand this idea. Whenever you deal with the fraction, you need to consider this both case. When you're dealing with the polynomial, you basically just have to see the first case. But when you're dealing with a fraction, you have to consider both of this. All right, just be clear on this. Okay, now let me do the last one and then we're done. Okay, now here, find the absolute maximum and absolute minimum of the given function on this interval. Okay, so we are finding the absolute maximum and absolute minimum. So whenever we deal with the absolute maximum and absolute minimum, obviously you get the interval. Okay, now the way we do this is, okay, I'll just show you the step. Okay, the first you have to again find the derivative of the given function. So the derivative of x cubed is 3x squared, right? Bring 3 down here, and x to the power 3 minus 1 is 2. Bring this 2 down here, so that will give 6. X to the power 2 minus 1 is just 1, and the derivative of 1 is 0, right? And then once you get this, now find the critical number of this. So to find the critical number, I have to set this equals to 0. So f prime of x is, well, 3x squared minus 6x is equals to 0. Okay, so now from these two, okay, from 3 and 6, I can factor out 3. And also from x squared and x, I can factor out x. And the remaining terms are x minus 2, right? So that means I will get, so from here, either 3x is equals to 0 or x minus 2 is equals to, x minus 2 is equals to 0. So from here, divide 3 on both sides, so x is equals to 0. And from here, x is equals to 2. Okay, so since we're dealing with a polynomial, this is a polynomial, right? So we're dealing with a polynomial, so yeah, you can just directly say that these two are critical number. Okay, now to find the absolute maximum and absolute minimum, what we're gonna do is, okay, so now we need to plug this in, this value to the original equation. Okay, now first let's do f of 0. So when I plug this to the original equation, we'll get 0 cubed minus 3 times 0 square plus 1, or we'll just get 1, right? Similarly, now f of 2 to the original equation. Okay, do that by yourself and you will get, well, this is not a quiz problem, right? I'm just saying, just to check this answer. You don't have to submit anything here. And similarly, now what we're going to do is, now you're going to take these end point of this intervals. So the end point here, the minimum point on this interval is -1, and the maximum point in this interval is 4. So, okay, first plug that -1 again to the original equation, and then you will get 3. And also plug that 4 to the original equation, and you will get 17. All right. So from here, if you see the maximum value we have here is this, right? So that means f of 4 is equals to 17 is absolute, let me just write ABS, which means absolute maximum, and the minimum value we have here is -3, right? So that means f2 is equals to -3 is absolute minimum. All right, so this is the way of getting absolute maximum and absolute minimum when a function is given in a certain interval. All right. Okay, so that's it for this video. Like I said, on Tuesday or for tomorrow, Tuesday lecture. Well, you won't see anything for Tuesday lecture. This is the Tuesday lecture, or this is also the Monday lecture. Monday and Tuesday both lectures. All right. Okay, make sure you guys do the WebAssign homework on time, and I will see you in the next video. All right, I'll see you in the Thursday video. All right, thank you.